Hi everyone. Okay, welcome to this practical 2 video that's going to be discussing the essentials for your practical 2. So what we're going to do is we're going to first just talk a bit again about the practical before we actually look at the connection of the practical components, and the following part of that will then be just the evaluation of the practical components, because we need you to have all of this as an understanding and also already connected within your breadboards coming to the practical to reduce the time that it will take you to complete the practical. Okay, so the first bit of information I've already covered in the practical discussion that we had, but effectively your practical 2 is a verification of Ohm's law. Ohm's law, what does it state? It should state to you that the voltage across an element is proportional to the current flowing through that element if the load is resistive, right? So that tells you about Ohm's law, and it tells you about linearity. If you remember with linearity, we say there's a linear relationship with the voltage across an element and the current flowing through that element, given that the resistance is constant. So you're going to be now testing this in this practical. And how the practical is set up in your lab guide, they tell you that you're going to have a source, and that source will be connected to a resistor. You will also connect to an ammeter. You should know that the ammeter is connected in series to your circuit, and then you should also have a voltmeter, which you should understand is connected in parallel to the resistance of the circuit, right? So the ammeter will measure the current flowing through the circuit, and by extension the current flowing on that resistor value, and the voltmeter will measure the voltage across the circuit. You should be able to also just measure all the voltages across. So you could measure the voltage there, you can measure the voltage there as well, so that you know how to use the voltmeter and the ammeter. Okay, so the practical says you're going to range the input voltage from 5 volts all the way to 30 volts. So you're going to have a table whereby you're going to have the input voltage. That's going to be 5, 10, 15, 20, 25, and 30. And what you're going to do is you need to measure the voltage of the resistor, and you measure the current flowing through the resistor, which should equal to the current of the circuit. Okay, so I take this to 5 volts, I measure the voltage, measure the current. 10 volts, measure the voltage, current, etc., all the way to get to 30 volts. And then you're going to plot a graph, and that graph should be a voltage as a function of current graph, and you need to, let's say it's a graph that looks like that, but that graph should basically indicate the relationship between voltage and current based on these values that you've measured. Okay, so this is the practical, and what changes is that first they say put a low resistor value, so you can put a 10 ohm resistor value or a 100 ohm resistor value, okay, as a low value. And then you put a high value, so we're going to put, let's say, a 5 to 10 kilo ohm resistor as the high value. And once you've done that, again you're going to go and you'll measure the voltage and the current across. So let's say that will be VR low, and that will be low, and that will be VR high, and that will be the current through the resistor high, and you measure those values, and then you'll plot the second graph of voltage versus current. Okay, and then you should be able to use this to make a conclusion in terms of Ohm's law and in terms of linearity. So this is just the theoretical discussion of your practical. And you need to remember that whatever it is that you are measuring here, you should be able to calculate it. So if you've put a 10 ohm resistor and you've got a 10 volt source, you should know what the current flowing through that circuit is. You should know what the voltage across that resistor will be already. So walking into the practical, have an idea of what these values should actually be before you actually calculate them, or before you actually do the measurement. Alright, so we're going to be taking a look at now the practical part of this that we're going to be required to do in the practical. So it was indicated in the lab guide that you need two measurement equipment, in other words, two multimeters. And you can see here I've got two multimeters that I'm going to connect. One is going to be used as a voltmeter, the other one is going to be used as an ammeter. I need a breadboard. We'll talk a bit about that as we see how to connect it. I need two resistors. So here I've got a 100 ohm resistor and I've got a 10 kilo ohm resistor. I've just added a diode as well just to show something, but you don't need the diode. I need my connection cables, so I've got a few of those. And as a power source, just for demonstration purposes, I'm going to be using a 9-volt battery. So you would need to get a 9-volt battery as well as your connection cable from that battery. In the practical, we're going to be using the power supply instead of this battery. All right, so your breadboard, you'll remember that in the internal configuration of the breadboard, as we had discussed, has vertical short circuits. Vertical short circuits there, that's what you see here. It's vertical short circuits, and then two horizontal lines going the positive and the negative there. So now, should we be in a position where we want to connect the circuit, so what we would do, let's say for example, we just want to connect one resistor to the circuit, then I will first connect my positive of the source to the positive of my battery, okay, and the negative of this horizontal line to the negative of my battery, right? Then from there, I can put another cable that's going to go from the positive to this horizontal line, and then from that horizontal line, I can connect a resistor. So I can connect a resistor, and then that resistor can continue to that horizontal and vertical line. Okay, and then from there I can take this out with another cable, and I can connect that to my negative, and my circuit is then complete. All right. And we're going to do something similar to that within our connection. The only thing is I'll just add a diode to that so that we can see that the circuit is complete when we are connecting the circuit. Right, so let's start off with that. So I'm going to start off by connecting my battery to the positive and to the negative. Actually, let's maybe wait with that. We leave that till the end. So I'm going to connect a positive output, my output of the positive, to one of my vertical lines. Okay, maybe take a bit lower there. And then from there, I'm going to connect my 10 kilo ohm resistor. Okay, so there's my 10 kilo ohm resistor. I can connect it anywhere in this line. That's it, right? So I'm going to connect it between there and there. So my 10 kilo ohm resistor is connected now. Then from there, I'm going to connect I'm going to connect the circuit to, and I must make sure it's on the same line so that it's in series. I connect that to the negative. Okay, and then I trace the circuit from the positive. It comes here, it goes into the one leg of the resistor. Remember, the resistors, the connection of the legs doesn't matter. Connect that leg goes straight there, it comes back to the negative. Now I can connect my source, and I can put the positive on the positive leg, I put the negative on the negative leg. Okay, and the source now should be connected and running. How can I make sure that actually something is happening there? So what I can do is I can use the voltmeter just to make sure that I'm actually getting some readings. So I'm going to put my voltage source, or my multimeter on volts, and I can measure the voltage across the resistor. Okay, and I'm going to just turn this around so that you can see it. Okay, so there's the voltage reading. So I'm going to put this across the resistor, positive and negative, and you can see there it says 9.5 volts. So that tells me that that circuit is connected. All right. What we can also do now, I'm just going to add my diode to the circuit just to make sure that, just to give a visual indication of the, the operation of the circuit. So I'm going to take the negative out. So you always take your source out when you're doing a connection, and then I can connect my diode. All right, and then after I've connected my diode, I complete my circuit. So I'm going to connect now the output of that circuit to the negative. And when I connect this negative leg now, it should actually switch that diode on, which is what you see there. So the diode goes on. So and now I know that the whole circuit, from the positive, it goes to the resistor, and then from the resistor it goes to the diode. From the diode it comes to the negative of the source. That's a complete circuit. And I can again measure the voltages. So I can measure the voltage across the resistor, and what do I get there? I get 7.9 volts. And then I can measure the voltage across the diode, and for that will be negative and this will be positive, and I get a voltage of 1.6 volts, right? And that will tell me that that should match up to the source voltage. All right, so what do we now need to do from here? I'm going to take out the I need to add the ammeter. So we're going to add the ammeter to the circuit. How is the ammeter connected? We know that the ammeter is connected in a series configuration. Okay, so I can connect it anywhere after or before, but we'll make it after the resistor. So here's my resistor. So after the resistor, I'm going to add my ammeter. And how I'm going to add it, I'm going to take this out. So I take my source out, I take my diode out, and then after my resistor, I'm going to put a cable here. For the positive of the ammeter, I'm going to put a cable for the negative of the ammeter, but that can go straight to the negative. So then I'll take this positive, connect it there, I take the negative, and I connect it to the negative leg of the ammeter. Okay, make sure that my ammeter is sitting on a particular voltage. How do I know which voltage, or which current rather? Well, I've got a 9-volt source. I've got a 9-volt source that I need to that is divided by a 10 kilo ohm resistance. Right, and that gives me a value in millivolts. I want to see what that is in millivolts. That gives me a value of 0.9 milliamps, rather, not really millivolts, but a value of 0.9 milliamps. So I'm going to put this in milliamps, so it's in milli. Right, and I will then put my source back on. All right, and once I put my source on, let's take a look. That's 200 milli. I can take this down. When you see that 1, it means it's a bit higher than it's overloaded. So I can take that down. Okay, and this is the current reading that I'm getting, and that will be in amps. All right, actually this would be this side. Okay, and that gives me a value of 0.98 milliamps. So that was AC current that I was reading there. So you must make sure that your multimeter is on DC current and DC voltage. Okay, so you can see that 0.9 milliamps, and then I can measure the voltage again across the resistor, and the voltage across the resistor will give us a value that's equal to the source voltage. So that gives me 9.57, right? So that should be the value that we're getting from the source itself. And then if I now want to change the resistor, I will take the source out, I take this resistor out, I'm going to put a 100 ohm resistor. Okay, and with a 100 ohm resistor, I'm expecting the current to be significantly larger, though the voltage will be the same. So I've connected my circuit back. I can see it's overloaded, that means the current is larger as we have expected. And now it's giving us a value of 80 milliamps, whilst the voltage is still the same, because the voltage value, let's just make sure they put this properly, and that should be positive and negative. Okay, and then let's make sure of, okay, so this would match the voltage, so it means the source itself now is discharging to a lower voltage, but that would be the voltage that's equivalent over the source itself. Okay. All right, so that's your practical. And the only thing that will change is that your source value will now be your DC power supply. And you're going to change that from 5 volts to 10 volts to 15 volts, 20 volts, 25, and 30 volts. And then you'll measure your current. So you saw here that we measured the first current at the high value. We found that the current at, let's call it 9 volts, we found that the voltage was 9, and we found the current to be 0.9, it was milliamps, right? And then with the higher resistor, the voltage would still be 9, but the current was, I think it was, let's say 75 milliamps. So you continue this experiment with different voltage values, and then you should be able to generate your plots and then make a conclusion in terms of Ohm's law. Okay, and for those of you that will be using the potentiometer instead of the two resistors, then this is the configuration that you'll need to have. We're just going to look at that quickly. So this is the potentiometer. It's got 3 legs. The first leg should go to VCC, and then your second leg and your third leg become your resistor. So your positive leg of the resistor and the negative leg of the resistor. Okay, so that's how I've just connected this circuit here. So I've got from VCC goes to the positive leg, it gives it a 9 volt reference, and then your second leg is the positive or the top leg of your resistor, and the third leg is the bottom leg of the resistor. And then what I've done is I've just connected the diode, and then I've connected that to the negative terminal. So when I switch this on, the diode should switch on to indicate that the circuit is complete and current is flowing, and that's what you see there. And essentially what you then need to do is the positive and the negative leg. So that positive leg you see there, I've connected it to the positive of my multimeter, and then the negative leg, which you can see there, I've connected to the negative of my multimeter. And I change my multimeter to ohms, right? That's how now you'll measure the resistance. You can also do this for the normal resistors when you want to measure the ohm value of the resistor. So I've set that to ohms, and what will then now happen is I can adjust the value of the resistance by turning this knob. So by turning this, you'll see there that the value will start to change, right? So currently it's saying 16 ohms, now it's saying 50, 51 ohms, it's going up, so now it's gone a bit higher. So currently there it says 1540 ohms, which is 1.5 kilowatt. So that would then be the usage of your potentiometer.